this lesson we're going to be talking about negative rational numbers. We're going to start off with some things that look fairly obvious, and you're going to be wondering what we're dragging our feet about, but I hope to make it obvious in a second. So let's consider the mixed number 5 3/8 is between 5 and 6. Okay, I'm going to throw those on the number line. Here could be 5, here could be 6. So 5 3/8 is in between, and I'm going to make marks to kind of make it look like eighths here. 1, 2, 3, 4, 5, 6, 7 marks. So 5 3/8 is right there. And of course, this means that 5 3/8 is greater than 5, and 5 3/8 is less than 6. Specifically, 5 3/8 is 3/8 more than 5. Well, that's great. But now let's consider the mixed number negative 9 3/4. So this is a negative rational number. And the two whole numbers that this is between are negative 10 and negative 9. So we'll put negative 10 on the number line, making sure to put it to the left because negative 10 is smaller than negative 9. Okay, now I'm going to break up the space in between into fourths. And so negative 9 3/4. This is where things might not be as intuitive to us, but negative 9 3/4, if we were counting from 0 way off to the right here, we'd eventually get to negative 9, and we continue negative 9 1/4, negative 9 2/4, and this would be negative 9 3/4. So therefore, negative 9 3/4 is greater than negative 10. It's to the right of it, so it's greater than it. And negative 9 3/4 is less than negative 9. So we've bounded negative 9 3/4 by two integers on either side of it. And now we can say specifically negative 9 3/4 is 3/4 less than negative 9. Here, unlike the previous example where the 3/8 moved it more, here the 3/4 is moving it less because the whole term here was negative. So now we're going to work on using that to help us convert mixed numbers to improper fractions. So let's go ahead and consider 40 over 8. Well, that's just 5, and 48 over 8, which is 6. So let's go ahead and plot them, but let's keep them as improper fractions. So if I put 40 over 8 there, and I put 48 over 8 there, I can remember that those numbers are 5 and 6, but we're writing them as improper fractions now. Since 5 3/8, as we said earlier, is 3/8 more than 5, if we start with 48ths, and we'll break this up in eighths, 1, 2, 3, 4, 5, 6. 3 more eighths would be 1, 2, 3, right there. So 3 more than 40, of course, is 43/8. And again, you're thinking, wow, I know how to convert mixed numbers into improper fractions. I don't need a number line to do this. So let's talk about that. What would be the quicker method that you would use for converting 5 3/8 to an improper fraction? So many of you, I'm going to write this a little bit bigger, are thinking in your mind something to the effect of take the whole number, multiply it by the denominator, and then add the numerator. So we get 5 times 8 plus 3 all over 8. Which gives us 40 plus 3 is 43/8. So what did we do? We multiplied the whole number. We multiplied the whole number by the denominator and added the numerator. Terrific. So another thing we can think about is that we could rewrite 5 3/8 as the sum of a whole number and a proper fraction. And this is fairly obvious. 5 3/8 is equal to 5, the whole number, plus 3/8, which is a proper fraction. Okay, of course, it is 3/8 more than 5. That's what 5 3/8 means. 5 plus 3/8. Well, let's get away from our nice, happy, positive mixed number to a negative mixed number. So let's consider negative 40 over 4, which is negative 10. And negative 36 over 4, which is negative 9. Let's plot those improper fractions again. So negative 40 over 4 and negative 36 over 4. Okay, so we're looking to try to plot negative 9 3/4, so we'll break up the space in between them into fourths. And we remember that negative 9 3/4 is 3/4 less than negative 9. So here is our negative 9, really, just disguised as negative 36/4. So we'll go 3/4 smaller. 1, 2, 3. So right there is our negative 9 3/4. What would we also think of that as? This could be negative 37/4, negative 38/4, so this must be negative 39/4. This might have been less intuitive for you to do without a number line, but we'd like to still get to a place where we don't have to draw a number line every time in order to convert even negative mixed numbers into improper fractions. So it's dangerous, but I'm actually going to show the mistake that I see a lot of students do. So this first step is wrong. So you might not even want to write this. So I see some students say, okay, negative 9 3/4. So I'm going to take negative 9 times 4. So they think negative 9 times 4, and then I'm going to add 3. Okay, negative 9 times 4 is negative 36, plus 3 is negative 33/4. We can see from up above, clearly that's wrong. And so I understand what students are doing. They're taking this whole number, but this time the whole number is negative. And then they're multiplying by the denominator and adding the numerator. However, the issue here is that they're not really considering that this numerator is also negative. The better way, I'll just call it the correct way, and I think is to ignore the negative sign for a minute. So we're just going to still do 9 3/4, do 9 times 4, plus 3. 9 times 4 is 36, plus 3 equals 39. Then we need to go back and remember that there was a negative here. So this whole expression is negative. So our answer is negative 39 over 4. So in a nutshell, save the negative for the end. Okay. Another way to kind of illustrate this point is to think about how would we write negative 9 3/4 as the sum of a whole number and a proper fraction. Again, this is where students are kind of making the mistake. So the wrong, and I'll write the wrong in red again, is they would say, oh, that's negative 9 plus 3/4. Well, think about that. That number, since we're adding a positive 3/4, that would make this bigger than negative 9. But we know that this is smaller. So that is incorrect. So to rewrite negative 9 3/4, it must be equal to negative 9 plus negative 3/4. So really, both the whole number and the fraction, the proper fraction part, they're both negative. That's negative, and this is making it more negative. So that's important when converting mixed numbers into improper fractions. Let's do a little bit of practice. Okay, so first we're going to convert each number to an improper fraction. Okay, so we see negative 5 and 5/9. So ignore the negative for a second. 5 times 9 is 45 plus 5. So that's 50. We're still over 9. Don't forget the negative. Now, the negative could go in the numerator. But this is also equivalent to negative 50 over 9, the negative kind of out front. Both of those are equivalent to each other. It doesn't matter at all which place you put the negative number there. Let's just try another one that might be a little sneaky. You're looking at number 17. You're like, how do I do that? It's not even a mixed number right now. Well, just like whole numbers, any negative integer can also be put over 1, and that's as simple as that is. So that would be how we make that into an improper fraction. Well, sometimes we want to go back from improper fractions to mixed numbers. So if I'm given something like negative 13 over 4, again, let's ignore the negative for just a minute. 13 over 4. 4 goes into 13 4 times and leaves one more left over. So that's 1/4, and let's tack on the negative. Terrific. Let's check out an example like 25. Ignore the negative for a second. 6 goes into 28 4 times. That gives us 24. It leaves 4 sixths left over. We can tack on our negative here, but notice that 4 sixths, that can be simplified. So this could be negative 4 and 2/3. You might have noticed at the beginning that this could have been negative 14/3. And either way that you want to go about it, you still want to get down to negative 4 and 2/3 as your final answer. Well, all of this is really leading us to the place where we can actually add, subtract, multiply, and divide negative rational numbers. So positive and negative numbers that include fractions and decimals and whole numbers, of course. So let's look at an example like 27. Nice thing we do notice in 27 is that we both are talking about fourths. So some people might feel comfortable trying to just add the whole numbers and the proper fraction parts, separately. For me, I just feel so much more comfortable going to impropers and then working on my way back. So 9 times 4 is 36, plus 3 is 39, so that's negative 39 over 4. And then we're adding to that. 5 times 4 is 20, plus 3 is 23 fourths. Okay, so negative 39 plus 23 is going to give us negative 16 over 4. Well, how nice is that? That just turns into negative 4. Terrific. Again, you might have been able to recognize that this negative applies to this 3/4. So that's negative 3/4. And this positive applies to this 3/4. So you have a negative 3/4 and a positive 3/4. So the 3/4 cancel out. And then you might recognize, okay, negative 9 plus 5 is negative 4. It just, in my opinion, leaves a lot of opportunity to make some errors. Okay, let's look at some other examples. All right, here we're adding a negative mixed number to a whole number. So here's an instance where it would be probably fairly simple to go ahead and not convert to improper fractions. I'll show it both ways. So since we have negative 5 and positive 3, we don't have to worry about combining any fractions. We can just recognize that that's going to be negative 2 and 2/5. If you want to convert it to improper fractions first, you can multiply. 5 times 5 is 25, plus 2 is 27 over 5, and make that negative. Now, how do we add 3? Well, we really have to make 3 into a number with a common denominator of 5, so that's going to be 15 fifths. Okay, and then if we're going to add those together, that gives us negative 12 fifths, which is also the same as negative 2 and 2/5. Terrific. Let's go ahead and look at an example like number 32. This often throws students off a bit. Some students can just straight up think about this, that we went 3/4 bigger. And so we're on our way towards negative 11. And so if we went 3/4 towards it, there's 1/4 more to go. And so some people might be able to just think negative 11 1/4. If you can't do that, you're going to need to convert that to a mixed number, to an improper fraction, sorry. If you convert that to an improper fraction, we're going to make it over 4s. So that's going to be negative 48 over 4, plus 3/4 gives us negative 45 over 4, which is still negative 11 1/4. There's a third method you could try. You could kind of borrow. So you could make this negative 11 4/4 plus 3/4. Here again, you do run into the issue of recognizing that this 4/4 is really a negative 4/4. And so if you add 3/4 and that, you are really subtracting negative 4, or you're adding negative 4 plus 3, and that would still get you to this same answer. To me, that seemed like perhaps the trickiest method of approaching that. There are nice examples where, let's look at, for instance, 31. Here, both quantities are negative. So remember, if we circle the sign in front, we have a negative number here and another negative number here. So this number is going to get more negative. So I do notice that they are not common denominators. So I'm going to go ahead and turn them into impropers first, and then make them common denominators, and then combine them. So let's ignore the negative for a second. 3 times 6 is 18, plus 5 is 23 sixths, and that's negative 23 sixths. And then we've got minus 2 times 4 is 8, plus 1 is 9 fourths. All right, now, unfortunately, we have sixths and fourths, but they can both become twelfths. So I'll make this first fraction into negative 46 twelfths by multiplying top and bottom by 2. And the second fraction we'll have to multiply by 3, so negative 27 twelfths. So now that both numbers have a common denominator of 12, we can add their numerators together. So negative 46 minus 27 is negative 73 twelfths. And 12 goes into 73 6 times and has 1 left over. And again, the whole number is negative. So our answer is negative 6 and 1 twelfths. 1 twelfth. There are also a couple examples of decimals in here. I don't think those should pose much of a problem. So when approaching decimal numbers, we might even want to just almost consider them like we would have considered whole numbers. So if you almost imagine that that's not there, you have negative 92 plus 4.7. So that would be negative 45, or in this case, negative 4.5. So decimal numbers, you don't have to obviously worry about common denominators or anything, so you just need to add those, keeping the place values aligned. One way you can think about decimals is to write them vertically aligned. So I'm going to write negative 9.2 plus 4.7. Now, the tie-in that we will kind of see between fractions and decimals is that this negative 9.2 means negative 9 and negative 0.2. So the 2, we can't take away 7 from 2, so we need to borrow. So we'll make the 9 into 8 and the 2 into 12. So 2 minus 7 is 5. 12 minus 7 is 5. And then we have negative 8 and positive 4. Negative 8 and positive 4 is negative 4. So we have negative 4.5. So thanks for watching us talk about how to convert negative mixed numbers into improper fractions and back again, and then how to use that to answer adding and subtracting problems involving positive and negative rational numbers.